Hello friends, welcome back to our channel. So today we will see what is the growth rate and the order of growth rates from smallest to the largest. So growth rate is a rate at which the time complexity of the algorithm will be changing or increasing based upon the increase of input size. So it is a rate at which execution time of an algorithm increases on increase of input, and usually this complexity will be denoted with the help of asymptotic notations. So we have seen the asymptotic notations in our previous session, so I'll post the link in the description so you can go through that one. So the complexity, it's a time complexity, is represented using asymptotic notations. So we know that asymptotic notations, so big O, big omega and big theta, so which we call it as a worst case. Next, this is a best case scenario, and this one is a average case scenario. Now we have to see the order of growth rate. So also we have seen different types of functions, right? So different types of functions: the constant, logarithmic, linear, quadratic, n log n, exponential, factorial. So like that we will be having a lot of functions, and we have to know the growth rate from smallest to the largest. That means which one will be the best and which one will be the worst. So based upon the execution time with increase of input. So that we call it as a growth rate, and in order to calculate the time complexity, we have to know the growth rate order. So if you know the order of growth rate, it will be simple while calculating the time complexity of any algorithm or any pseudocode. Now we will see the order of growth rate from smallest to largest. And always the time complexity will be represented using big O notation. That means a worst case notation, worst case scenario, right? So the order of growth rate of different functions, So from smallest to largest, I'll write here smallest to largest. So the first one will be the constant. So order big O of 1, it is a constant. And the next category, that means in the next level we will be having a one more which is a log n, which is a logarithmic. And the next one is order of n, which is a linear. Next, which is a n log n. That's nothing but we can call it as a linear arithmetic. And then order of n square. N square is nothing but a quadratic. Next, order of n cube, which is a cubic. Next, order of 2 power n, which is exponential. exponential, right? So example for this one is arithmetic operations, all arithmetic operations, okay, addition, subtraction, multiplication. And coming to the log n, it's a binary search, where the search space will be reduced every time. And this is a linear search, that means searching the element in a sorted order, searching the element in unsorted order. And n log n, we can say it's a merge sort with divide and conquer. And quadratic, we can say it's a bubble sort, where we are comparing two consecutive elements. And NQ, so matrix multiplication, so where we are using some three different for loops, okay, three for loops, right? So this is a towers of Hanoi, right? So towers of Hanoi problem. So towers of Hanoi problem comes with this exponential. Okay, so these are the functions, the names of the functions, and the example for these particular notations, right? And this is from smallest to largest. Okay, so the time taken for the constant will be less when compared to exponential, and exponential will be having more number of steps required to complete its execution when compared to the constant. So this will be from smallest to largest, and we can also call it as a best case to worst case. So already we have represented with an asymptotic notation order, that means a big O notation. That's a worst case scenario, right? So what here, this will be the order, smallest to largest. And this table will be more important and will be more useful when you are trying to calculate the time complexity of any algorithm. Okay, so that's why I am writing the complete overview of all the functions, growth rate, order of growth rate, right? So hope you understood. In our further sessions, we will see how to calculate the time complexities from simple code to complex code. So let's stop here. If you are having any doubts regarding this one, feel free to post your doubts in the comment section. Definitely I will try to clarify all your doubts. If you really enjoyed my session, like my session, share my session with your friends, and don't forget to subscribe to our channel. Thanks for watching. Thank you very much.